We're going to take a look at some right triangle trigonometry, focusing on the big three: sine, cosine, and tangent. So, in geometry class, you learned about three trigonometric ratios: sine, cosine, and tangent. So we have a right triangle, and we'll focus on angle A in this right triangle. Um, the side opposite angle A, if we start at angle A and go through the triangle until we hit a wall, that wall is the opposite side. The hypotenuse is the opposite side in the right triangle. The right angle box is sort of like an arrow pointing towards the hypotenuse. And then adjacent is our third side. Adjacent means next to. So opposite, hypotenuse, and adjacent. So we have the sine of angle A is a ratio of the opposite side length to the length of the hypotenuse. We have the cosine of angle A is a ratio of the adjacent side length divided by the hypotenuse. And we have the tangent of angle A is the opposite side length divided by the adjacent side length. So most people remember this as SOH-CAH-TOA, where sine is opposite over hypotenuse, that's the SO. Cosine is adjacent over hypotenuse, that's the CA. And tangent is opposite over adjacent, that's the TOA. So usually remember this as SOH-CAH-TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And sometimes we need to use the Pythagorean theorem, a squared plus b squared is c squared, in order to find any missing sides. So friendly reminder that a and b could either be the base or the height in any order, but c is always the hypotenuse in the right triangle when using Pythagorean theorem. All right, so example 1a, we're going to write the exact ratios for sine, cosine, and tangent for angle A. So for angle A, we have the opposite is 8, the hypotenuse is 17, and our adjacent side is 15. So the sine of angle A, opposite 8 over hypotenuse 17, or 8/17. Cosine of angle A, adjacent over hypotenuse, or 15 over 17. So cosine of angle A is 15/17. And tangent of angle A, opposite over adjacent, 8 over 15, or 8/15. All right, part B, here we have opposite is 3, hypotenuse is 5, adjacent is 4. So our sine of angle A is opposite 3 over hypotenuse 5, or 3/5. So the sine of angle A is 3/5. Cosine of angle A is adjacent over hypotenuse, which in this case is going to be 4 over 5, or 4/5. And then tangent of angle A, opposite over adjacent, is 3 over 4, or 3/4. All right, example 1c. Notice in example 1c we have the opposite side of angle A and we have the adjacent side of angle A. We're missing the hypotenuse. So we need to calculate the length of the hypotenuse. And to do that, we're going to use Pythagorean theorem with 9 squared plus 15 squared equals c squared. So 9 squared is 81, 15 squared is 225, and when we get and add those together, 81 and 225 is 306. So the hypotenuse is the square root of 306, which simplifies as 3 times the square root of 34. So it's the square root of 9 times the square root of 34 will give you the square root of 306. So it's the square root of 9 is 3 times the square root of 34. Be sure to check my Desmos video on how to use Desmos for simplifying square roots, exact square roots. So now we have the hypotenuse as 3 times the square root of 34. Now we can write our ratios. So first up, sine of angle A, 15 over 3 times the square root of 34. And 15 over 3, we can actually reduce that to 5 over 1. So we have 5. 15 over 3 is 5 over 1 times the square root of 34. And we're not allowed to have square roots or any radicals in denominators, so we need to rationalize our denominator. And going back to radical expressions, in order to do that, we multiply the numerator and denominator by the square root of 34. So we take the numerator and denominator and multiply them both by the square root of 34. Essentially whatever's in the denominator. So on top we have 5 times the square root of 34. We can't do anything with that. But on the bottom, square root of 34 times square root of 34 is just 34. So we have 5 times the square root of 34 over 34 for the sine of angle A. All right, next up, cosine of angle A is going to be adjacent over hypotenuse, or 9 over 3 times the square root of 34. So 9 over 3, those are both not inside of a radical, so we can divide 9 by 3 as 3, or 3 over 1. So cosine of angle A is 3 over the square root of 34. And rationalizing this one, we have to multiply the numerator and denominator by square root of 34. So when we do that, on top we get 3 times the square root of 34, and on the bottom again we get 34. All right, last up, tangent of angle A. Tangent of angle A is going to be opposite 15 over adjacent 9, and that reduces 15 over 9 reduces to 5/3. So that about wraps it up for this video. In the next video, we're going to take a look at the reciprocals of sine, cosine, and tangent, called cosecant, secant, and cotangent. So I'll see you.